Hello everyone, in this video we will be going to perform how to clean textual data in Python. So first of all what I am going to do, I have to download this data set. So I am going to this link which is a Kaggle website and the data set name is Elon Musk tweet dataset. I will be providing this data set in the description. And what you have to do, you have to log in into the Kaggle account and you have to click on download this CSV file. Click on here and it will be get downloaded. Once this thing is done, after that what you have to do, you have to upload this data set in the Google Colab. So let me click on here and just click on upload. And the file name is tesla.csv. So let me upload this file and done. So this is your first step in which you have to download the data set from Kaggle and upload it in the Google Colab environment. Once this step is completed, the first thing that you have to do, you have to install all the important libraries. So these are the important libraries that I am going to install. Word cloud and emoji. So what is a word cloud? Word cloud basically means a visual representation of the textual data. Let me show you some image here. So here we can see this is the word clouds. You can see visual representation of the textual data. If the size of the word is more, it means the frequency of that particular word is high. So here we can see big data. So this frequency of big and data is very high in the document. That's why it is appearing very big. Similarly, if the font size is very small, it means it is the frequency will be very less. So this is basically your word cloud. After that, we are downloading the emoji library. Emoji library basically means you are dealing with the emojis kind of text. So for that purpose, I am going to use emoji library. And here I have written -q. -q basically means I am downloading all this library in a quiet mode. So let me run this out. You can see I have downloaded this library. After that, what I am going to do, I am going to import all the necessary libraries. So first of all, I am going to import pandas. So we all know that pandas is used for loading the data and perform data cleaning operation on it. Then we have matplotlib and seaborn. These two are useful for data visualization. Then we have numpy, which is used for mathematical operation like calculating mean, median, mode, all sorts of things we can do with using numpy. Then we have emoji for dealing with emojis kind of data. Then from the word cloud, I am going to import word cloud and the stop words. You all know what stop words is? The most frequent word in the document. For example, is, am, are, why, how, then. These are all the most frequent word in the document. That's why they are called as stop words. Then we have RE. RE module is basically the regular expression module which we have studied in Python. Then we have NLTK. NLTK basically stands for Natural Language Toolkit. Natural Language Toolkit means it will helpful for performing text data cleaning. After that, from nltk.corpus, I am going to import stop words again. Then for the lemmatization purpose, I am going to use wordnet lematizer. And for the tokenization function, I am going to use word_tokenize function. And at last, I am going to use warning module to ignore any types of warning present in my code. So let me run this out. Once you have imported all this library, the next step is to download some pre-dependencies. So these are the dependencies that you need to download. So here I am downloading the stop word, then I am downloading the punct tokenizer, then I am downloading the punct_tab tokenizer, then we are downloading wordnet lematizer. So these are the dependencies needed in order to run this code. So the goal of the project is basically performing the data cleaning. So here we can see all my dependencies are installed. Now what I have to do? I have to import this data set which is tesla.csv. So let me use the pandas library. So here we can see I am using the pandas.read_csv function in order to load this tesla.csv file. Once it is loaded, I am going to display the top 5 rows of the data set with the help of df.head function. Here we can see it is displaying me the 5 rows and 39 columns. Now I don't need all the columns, I need only specific column. So what I can do, I will take the subset of the data set. So here I am selecting only created at and the tweet column, which is here. Rest everything I am going to ignore. So let me just check it out. So this is my data set that I am going to work upon. Once you have loaded the data set and selected the important column, after that what I have to do, I have to check the shape of the data set. So here we can see with the help of shape function, I am going to check the shape of the data set. So data set shape is, you can see 10,000 rows and we have 2 columns. After that, I am going to check the info about the data set. Info basically means showing the information about the data set. So here we can see the created at column is a float type, the tweet column is of object type, and the memory usage is around 156.6 plus KB. So this is my memory usage. Now I am going to check for any missing values. So with the help of isNA.sum function, I am going to check for the missing values in the data frame. So here we can see there is no missing values present in my data set. After that, what I am going to do, I am going to check for the duplicate values. So here we can see with the help of duplicated.sum function, I am going to check for the duplicate values. Currently you can see there are 0 duplicate values present in my data set. Next, I am going to define my contraction. So let us understand what do you mean by contraction. Contraction means you are expanding the short form into the long form. Let us see this. So here we can see this is the example we have given, like I don't have car. So if I expand this out, so the meaning will be I do not have car. So here we can see if I expand this out, so I do not have car. So this is the contracted word. Now if you go to this link, a list of contraction is given to us. So let me open this out. You can see a list of contraction is given to us. So these are the contraction, like ant will be replaced with am not, aren't will be replaced with are not, can't will be replaced with cannot. So these are all the contraction we have. Now what I am also going to do in this, I am also going to include the slang words. Slang words are basically like this. Here we can see, for example, LMK. LMK basically means let me know. FYI. So these are some slang words I am going to replace with the full form. Like FYI means for your information. NVM means never mind. So this is the contraction that I am going to define in the format of a dictionary. It will contain 2 things. This thing first of all, and the second thing it will contain the slang words like IDK means I do not know. So this is my contraction dictionary. Next, what I am going to do, I am going to apply text data cleaning. So here we can see this is the text I have given to us. So what is the first step that you are going to do in text data cleaning is you will be converting this thing into lowercase. So I am going to use text.lower function in order to convert this text into lowercase. So let me just write here text and let me run this out. So here I have run this out and you can see all the things are converted in the lower case. Next, what I am going to do, I will be going to handle the contraction, like this don't will be replaced with do not. So for this purpose, I am going to, first of all, I will be splitting the data set. So let me split the data set here. So here we can see all the words have been splitted. If you remember, each individual word is called as token. Next, I am going to create an empty dictionary. Then I am going to iterate through this splitted word. And if any contraction word is found, what we will be going to do? We will be going to expand this out. For example, don't will be replaced with do not. And then I am going to print my new text. So let us see here. You can see don't will be replaced with do not. So this is my contracted words. Now you can see next what I have to do, I have to join back again. So these are individual words, right? Now I have to join back in the sentence. For that purpose, I am going to use join function. So the delimiter is basically a space and this is my joined word. Now you can see we have done the first two steps. We have converted the text into lowercase. After that, we deal with the short form words and replace with their full form. The third step will be to remove the URLs. You can see there is one URL present. Now what I am going to do, I am going to remove this URL. So for this purpose, I am going to use regular expression. So here we can see, first of all, I have written regular expression dot substitute. If anything which is started with HTTPS, remove this out with an empty string. So what this thing will do, you can see my link will be get removed. So this is my third step where I have to remove my URL. Next thing that I have to do, if there is any username present like this, you can see here @Elon Musk, @something. So what I will do, I will deal with the username. That will be my step number 4. So here we can see anything which is started with @, then capital A to Z, small a to Z or 0 to 9, everything I will be going to replace with the empty string. So currently you can see there is no @ mentioned. So it will be same as it is. So let me just write it out. You can see. Next what I am going to do, I am going to remove any sorts of symbol. Like here we have one symbol like this exclamation mark and another symbol is basically the emojis. So what I will do, I will remove any extra symbols present in my text. So for this purpose, I am going to use all these regular expression thing. So first of all, I am going to remove, let us say, ampersand tags. So ampersand tags basically means HTML tags that we have studied in HTMLs. Like BR tag is there for breaking the things, /n is there for next line. So all these things I am going to remove. Any sorts of symbol, I am going to remove it up. Once this thing is done, what I am going to do next, you can see currently my text contain emojis. So there are various types of emojis we have, and emojis are basically denoted using Unicode character. So what I have to do, I have to define a list of Unicode character and then I have to replace this emoji. So here we can see I am defining a bunch of Unicode characters and after that I am replacing this with a empty string. Now let me run this out and you can see my emoji has been removed. Once your step 6 will be done, the next step what you have to do, you have to perform tokenization. So here I am going to simply perform the tokenization. So here we can see this is my tokenization. Next thing what you have to do, you have to remove the stop words. So if you remember, stop words are the most common words in the document, like I, do, these are the most common words in the document. So what I will do, I will remove the stop words. Currently my language is English, so I am going to use English stop words. So here we can see, first of all, I am selecting all the English stop words. Then I am going to use list comprehension syntax. So here we can see, this is my output word, then my for loop, then my if conditional statement, and this is my cleaned word. So you can see all the stop words has been removed and only the important words will be there. Next, what I am going to do in step number 9, I am going to apply lemmatization. What do you mean by lemmatization? So if you remember in our previous class, lemmatization basically reduces the word to their root form, but it always have meaning. So if there is anything like, let us say, best will be converted into good. So it will convert the word into their root form. So this is what lemmatization will do. The process is slow, but the things that we are using is, because it is too accurate, that's why you are using lemmatization. And it always have meaning, unless like stemming that does not have any meaning. So here lemmatization will always have meaning. So here we can see I'm going to initialize wordnet lemmatizer. After that, I'm going to use list comprehension syntax here, where I'm going to lemmatize this word from this word. So here we can see this is my lemmatization. Currently you can see everything is in root form, so there is no lemmatization applied here. But if there is any other thing like we have reduced, so reduced will be converted into reduce. So this is my step 9, and this is all about text data preprocessing. Now what I will do, I will combine all this step 9, like step 1 to step 9, like I will combine all these steps and I will define it in a function. So here we can see I have defined everything inside a function. Like here we can see function name is clean text. It is taking the text and it is removing the stop word set to true. Convert the text into lowercase, then dealing with the contraction, removing the URL, removing the username, removing any irrelevant symbol, then I am removing the emoji, then I am tokenizing the text, and then I am removing the stop words, and then I am lemmatizing the things. So this is my function. From step 1 to step 9, all the things is implemented inside a function. Now what we will do after this, we will implement this function on that data frame that we have created. Here we can see this is the data frame we have. Now I will apply this function on this tweet column. So let me do that. So here we can see this is my new column named as clean tweet. This is my old column tweet, and I am going to apply this clean tweet function with the help of lambda expression. So let me run this out. And you can see this is my clean tweet column got created. Next what I have to do, I have to process this created at column also. So I am going to import date time, and then I am going to take this column created at and I will convert into pandas date time, and the unit will be millisecond. Now if I run this out, you can see this is my created at column. Now everything is processed. So this is my all about text data cleaning.